looked at for our expression in the previous video. And truth tables are great for describing how an equation works for all possible inputs. However, these equations are eventually going to end up becoming circuits. We're getting very close to being able to simulate our own circuits. And when it comes to simulating circuits, truth tables, while useful, do not do a good job of describing the behavior of a circuit itself. When we're simulating a circuit, when we're modeling a circuit, we want to be able to supply different inputs and actually view those inputs, how those inputs affect the output over time. So we need to have some way of incorporating time into our results. And so that's where timing diagrams come in. I've actually created a timing diagram for this particular equation that you can see on this particular slide. And so the way to read this is on the left side we see our various signals. These first four signals are our inputs. This last signal here is our output. And so based on what these four signals are doing, that should affect the output, right? Typically in a simulation I can change what these four input values are. I cannot change the output. The output's going to be based on how my circuit is being simulated. Across the top here I can see actual timing information. So you can see these that probably represent milliseconds or microseconds, actually might be more accurate, right? So this is how my signals are changing across time. And you'll notice that once all of my signals start out low and then I raise A now becomes high. And so what I have is A is high, B, C, and D are all low. So we can actually look that value up on this chart and we should be able to see how Z is going to behave. So here's where A is high, the remaining signals are low, they're false. Z should be false, which in fact it is, right? But if I plug in a different configuration for my inputs, here I see B is high, C is high, A and D are in fact low. If I go back to my truth table, I should be able to look up that particular condition. Here it is right here, this particular row. I see that the result should be true, which in fact it is, right? So what a timing diagram represents is how a circuit behaves over time. It is still obeying the rules set forth in this truth table and laid out by Boolean algebra, but these timing diagrams are much more useful when simulating circuits, when testing the design of your particular circuits. And you'll be seeing them more and more as we start to build and design our own circuits in this particular class.